I promise you I did everything I could to fit this thing into 20 minutes. I will do my best to do so. If you can see that box there, that is an oscilloscope, because originally I planned to show you something on that as well, but I already threw out the idea just to make sure that we are going to be able to finish in time. So yeah, about this presentation, let's first talk about myself, but really just roughly. I am a cloud architect at Alice. I've been working for this company for more than 10 years now. And soon after I joined Alice, I had to realize that Alice is not just an IT company, but actually it can be your private travel agency, if you will. And this is how I got to Dubai for a wonderful half year, and then after that I got to Singapore. I lived there for almost 1 year. Fun fact is that these are quite hot places, right? And I don't really like that, so I much prefer the cold weather, but this is just a side note. So, more about the context. Let's talk about Singapore a little bit. You can see these figures, right? So, if you are not familiar with that, the minimum temperature is 24 Celsius degrees. In 1938, I think, that was the record minimum temperature that was just below 20 degrees. So this is how warm Singapore is. And beside that, you can see the average humidity. So yeah, this is a place where I sweat a lot. This is literally something like you go out and in 2 seconds you're swimming in your sweat. So in this context, I was commuting home. That's again me. Yeah, I promise I won't talk too much about myself, but I have to sometimes. So I was traveling home, and I was wondering that, Jesus Christ, by the time I got home to the condo, there is going to be like 40 degrees. So it's extremely hot. So I started to play with an imagination where I'm doing the same, like traveling home, but have the option to push some buttons on my phone so that somehow I turn on the AC. So by the time I arrive home, I can get into a comfortable temperature. Yeah, those are not mine. So I didn't have money to buy either AC or the condo itself. It was there. So this is an important fact, because this information is needed to be able to build up the specs for this little project. Because I thought that let's realize this idea. So what are the functional requirements? Fairly easy. I want to be able to turn on the AC, right? And the second requirement is that I should be able to do that anytime during the day, because it's unpredictable that what is the time when I get home. So the timer solution is not going to work. The non-functional requirements, unfortunately, I didn't own the condo and I didn't own the AC unit as well. So I didn't want to do like investment for upgrading the unit to a smart one. That was a really old Daikin AC, and I didn't have the option to do any modification on that unit. So yeah, this is the context. I don't know why Siri wants to hear something, but no worries, go away. Yeah. All right. So as you can see, we don't have an AC unit here, but I wanted to show you something. So I brought in this fan, and this is what I am going to turn on and off. So just to be able to demonstrate something, because just talking about these things wouldn't make too much sense. So let's go. So how can I achieve these goals? The trivial thing is just to fake the remote control signal, right? So that's how I can turn on the AC. It's not going to need any kind of serious modification on the unit, so fits perfectly to our case. So let's do first. I thought that it should be easy, because I had this weird hobby, this IoT thing, possibly on the lowest level, so just to make sure that it is going to start like coding in assembly and things like that was really my thing for years. So I did some interesting projects. I don't have too much time to talk about those, but in case you are interested after the presentation, I will. Now for those who doesn't really know how exactly the infrared remote controller works, what's happening is that it's communicating towards the controlled unit through infrared light, right? That's not so strange. But the thing is that in our environment there is a lot of different things that are emitting infrared light. So our body, any heat results in infrared light, also the radiation from the sun. So just by turning on a LED and turning it off, it is not necessarily distinguishable from the environmental factors, right? So somehow we need to modify this to make sure that it is identifiable and to make sure that it's coming from some kind of unit that we built, right? So this is why there is a carrier frequency. You can see it on the top. So with a certain frequency, this light is cut off. So actually that is just a very, very fast flashing. And what you do, so here the bottom line is that if you want to code the message, you can code with like either sending something with the light or not, right? So these are the two states. In IT, everything is 0 and 1. So essentially what is happening that either there are bursts of these signals or nothing is happening. And if you do a good timing and encoding and things like that, then you will be able to communicate with these signals. All right. So my first task, to be able to reproduce the signal, I should understand the signal, right? So I should see that. So my first task was to build something which is capable of capturing that. Now, I have another weird thing that I love these ESP devices. They have connectivity, they have built-in Wi-Fi chip, they have built-in Bluetooth chip, and they are like really dirty cheap. So I always have at least 5 with me anywhere I go. And this is why it was a trivial choice to use one of that. Obviously, I could use, for example, Raspberry Pi, but that's a little bit more expensive. And if you want to do like very low-level precise timing, most probably it's not your thing. It's hard to do with that. So yeah, what did I do? The first arrow shows the remote control. This is an actual picture from the project from 2019. That is the remote controller. I had to push the button that emitted an infrared light that went to the TSOP sensor, which is essentially just an infrared sensor which is capable of recognizing or filtering out the carrier signal. So this 38 kilohertz infrared signal. And when it gets it, it shows me 0, and when it doesn't get it, it shows me 1. And this is what my microcontroller reads. Now, after that, the microcontroller prints the information out on the UART interface, the serial interface, which is connected to my PC on USB. So I get that information to the PC, and there is already a comfortable environment to be able to analyze this signal, right? So this is what I built first, and this is going to be my first demo. So let me switch to that one. Here, what you can see is that this thing is already picking up something down here. So this is the serial log. If I grab this remote controller and find this little beauty, I sent a signal to that. Then you can see that there is a burst of information there. What is logged there, that what is the timestamp of the change and what was the change from 0 to 1 or from 1 to 0. This is all the information I print out. Now, next to that, in the background, there is a tool that is running, reading this information, packaging it into a more comfortable format, and exposes that through a REST API to a web UI that I built for visualization. So if I put a refresh here, then I can see that there are quite a few signals already that came, and this is the latest one. Yeah, 714. If I put it here to the display column, I can see that what is happening there. So I can dig into the analyzation of the signal, and I can see the timeline below that. Now, this is a signal of turning on the AC. If I want to compare that with other signals, I have already saved signals here. So for example, let me show you how I compare the on and off. You can see that most of the signal is quite same, and here is the difference. So if I zoom on that difference, then it will be more visible, I guess. Yeah. So here you can see that this is the difference between turning on and off the unit. Now I don't want to go too deep into how this message is encoded. What is important here that in the beginning I have some kind of weird frame that doesn't fit into the message. This is called start bit or synchronization point or whatsoever, a lot of name it has. And in the end there is another one which is a signal to the receiver that okay, I finished the transmission. And in between there is the message. And now this is a fairly stupid message. The AC controller had much more difficult things, but this is something that I can already demonstrate. So let's go back to the presentation. So how can we proceed? Now we need to take control, right? So let's assume that we decoded this message. We understand that how to construct a message that does something with the target unit. So now we want to reproduce that. What do we need? We need again something which is capable for precise timing, driving an infrared LED. Obviously we need some infrared LED to be able to emit the light, and then some wires to connect things, and then we need the target unit, right, that we want to turn on and off. Now what is going to be our architecture? This is fairly simple, so I think it looks complicated than it is, but I couldn't draw it more simple. So what's happening here is that I have a web UI, right, which is my interface that is in the center. That's what I open. Obviously that needs some authentication, which ensures that no authorized access is possible to the web UI I'm using. In the background there is some kind of backend which is currently deployed on Cloud Function. I have some DB where I store things about logs, that what happened and when and these kind of things. And also I have a service which is provided by Google Cloud, which is capable of keeping the connection with my unit, and that ensures the two-direction communication. Now going down a little bit, for those who are interested on the unit, on the ESP32, I like using Mongoose OS. Not sure, is there anyone who knows that? So that is built on the Mongoose networking library. Yeah, Gabor knows that obviously. That's built on the Mongoose networking library. Its task is to provide network connectivity with all of the full-blown features on very, very limited devices as well. So that's for embedded application, and it turned out that it works so well that they built an operation system around that. And yeah, it's really, really good, very, very easy, but you still have the low-level control. So I think that's a very good trade-off. Also, it had a GCP IoT core library, so that is something that I didn't need to take care about. I just started using it and it worked. Now, what is the IoT core? IoT core is a service from Google which you don't want to use anymore because they are going to retire that. But a very, very similar service is provided by most of the major cloud providers. So feel free to use those because Google doesn't have this. So it has an MQTT bridge that ensures the bidirectional communication protocol with proper security. So it supports TLS. It supports a device shadow. That is again something which is very important, and typically these kind of IoT services support that. So what it does is that it stores the last state of your device, and whenever your device is reconnected, it automatically sends it down. So after the connection gets established between the device and your cloud, whatever happened while the device was offline is automatically going to be synchronized down to the device, so everything is going to be in sync. And it has a REST API, so this is how my backend communicates with this service and through this service to the device. All right, how can we? What else we have? We have Cloud Functions. Well, this is just a serverless environment on GCP where you can create backend services with a few lines of code. It supports a lot of programming languages whatsoever. And the other thing is that nowadays these services are so cheap, really. This didn't cost for me anything. I didn't pay anything for operating this for 2 years, really. Usually when you subscribe to these kind of cloud providers, to these services, you have a certain amount of free quota that you can use for free. And after you go above that threshold, you generate more data, you use the services more, things like that. Then you can start finding bills in your inbox. But even those bills in the beginning, especially if you are doing this for home use, you need to make something seriously wrong to blow it up too much. So that's maximum a few dollars. Going back to what did I use? I used Firebase for hosting and authentication. I think authentication service is something that's worth to mention because it's seriously underrated, I think. So what it can do is that it's a full-blown authentication architecture. It has UI components, pre-built UI components. It supports all of the major social services to be able to link the accounts. It supports like custom authentication based on phone number or email address and all of those things that you don't need to take care about. So that's a wonderful thing. The Firebase hosting, again, that's another very nice thing. So that's just basically like a hosting thing that gives you DNS name and a domain name, and you can store static content there, and it's available everywhere globally. So that's again a nice thing. And generally, Firebase, that is basically a collection of different products. Usually, the base products can be found on GCP, on Google Cloud Platform, but they encapsulate those sometimes to make it more easy to use for like typically for hobby projects or mobile development or these kind of things. So that's a nice thing. I like to use that for prototyping because it's blazing fast. Like it's very easy to make progress with that. And then I use the Firestore DB. Why I use the Firestore DB, that was a trivial answer for NoSQL documents. I didn't want to go with the relational database and all of the cumbersome things that comes with that. And it has a lot of powerful features for UI development. So for example, you can define like declarative rules for your data, like who can access in what circumstances to what, and then your data is secured. And it has very strong JavaScript and TypeScript libraries through which you can subscribe to modification, for example. So you don't need to pull your backend, you don't need to deal with WebSockets and things like that to keep your UI updated, but it is going to happen automatically because this client library handles everything. And this is actually a key feature in Firestore. All right, so now comes the second demo. Let me show you what I built. This is the UI, nice, right? So what can I do here? I can add more devices, but currently I have a single one, this AC demo. AC controller is my device ID. I can see that currently it's turned off. Another thing, another feature that I built in, that I added a sensor as well to this thing, which is a temperature and humidity sensor. So this is how it reports what is the current temperature here and what is the current humidity. I wanted to use this for like automatic adjustment of the AC and things like that, but I couldn't go that far. So yeah, what I can do is to rename this thing, and if I click on the remote controller, then a UI comes up where I can configure everything. Now, this UI covers every capability of the AC unit that I had in Singapore. As I mentioned, I couldn't bring it home with me. So currently what it supports is it's able to turn on and off this thing and maybe turn on the swing. Yeah, these are the two features I implemented. So if I say that, I just toggle this button and I say save, then hopefully it is going to turn on. Yeah, there you go. So yeah. Actually, this is what I wanted to show you on the oscilloscope, because on the oscilloscope, instead of this signal, you could see the 38 kilohertz burst within those positive signs that you see here. But yeah, maybe that's not that interesting. Or if it is, we can stay and continue. Okay, so I took control. Now, how to proceed? Let me turn this off because maybe it disturbs the mic. All right, so let's move on very, very fast. How can I hand it over to the Google Assistant for control, right? So do you know Google Assistant? Yeah, so they manufacture also these kind of Google Home devices that you can put down in your home, and it listens to your commands and it tries to answer your questions. When you have smart devices at home, you can connect to that so it can control those. And this is how I thought that maybe I can build something that integrates to the Google Home, and through Google Home I will be able to control my device. At this point, this was only technical curiosity. So there were already like competing products on the market, I know that, but I wanted to understand how these things are working. So to be able to proceed, let's have a look at how the Google Home graph is built up, which means that how these devices are put into structure when we are talking about Google Home. So the structure is called Google Home graph. In this graph, there are homes. You can have multiple homes. For example, if you have smart devices in your office and smart devices at home and in your garage, and those are in different locations, then you can call them homes. Multiple families, whatever. Yeah, this is a structure, a place that has a dedicated address, and you live there or you use that place. Within this place you have rooms. This is not too surprising. You can name these rooms, and there are default rooms like bedroom and these kind of things. And then within the rooms you have the device, right? And device are the controllable things within the rooms. And we actually built this. So the device is what we built. Now, how the devices are described. The devices has types and traits. The type describes what kind of device is that, and depending on what kind is that, you can assign traits to this device. So for example, the AC controller unit is one type of device. There are ovens, there are, I don't know, smart lights, there are a lot of other smart devices. This is an AC controlling air conditioning unit, and it has a few traits. The traits I implemented is the on-off trait. This is what describes the feature that this device can be turned on and off. The temperature setting is another trait that means that you can set the temperature on that specific device, and the device is going to try to reproduce that temperature. And it has the option also to report the temperature. There is a fan speed option, and there are toggles. Toggles are like features like setting the AC to swing mode and these kind of things. So this is how I can describe my device. Now to be able to put a big picture together, I want to simplify my architecture diagram. So what you see in the first place, on the left side, I transformed that to this one, which can be found on the right side. So this little thing, this is the unit. This thing is this huge bubble, and this is me and my phone. So how should it work, right? So first of all, we need to configure Google Home, which means that I need to be able to add my device to the Google Home. I need to authorize the Google Home backend to use my backend to control my device, right? So what happens is, in this place, is that Google requires you to implement OAuth2 authentication in your service, and through that, with the standard authorization flow, you can grant access to the devices for Google. After that, you need to implement some necessary interfaces. That is trivial, right? So Google should understand what kind of devices you have, what are the capabilities of your devices, and what is the state of your devices, and also need to be able to comment on your devices. And then, and then you can use your appliances. So yeah, this is the account link. I don't want to go deep into that. I think this is important. So this is the backend you need to implement, where there is a sync intent. This is happening. This is an API call. Each of these are API calls. The sync is happening when you link your account. There is a query from Google to understand that how many devices of that type you have. The query intent is serving the purpose to be able to query the actual state of the device. The execute intent is for control, and the disconnect intent is when you want to remove the device from your home, then this disconnect is going to be code, so you can revoke the access of Google. Now, let's see how does it work. So I go to Google Home. Can you see that? You can see that, right? Okay, and I already linked the account, so the AC device is already there. And here I can see that the AC device is off, so I click it to turn on, then you can see that it turns on the device. So this is how I handed over the, how can I exit from this? Yeah. To the Google Assistant. Now, this was fairly quick, and usually it's not like that. Did you see, yeah, most probably you remember that how long did it take when I pushed the button on the UI, and it took time to turn on the AC, right? So if Google Assistant uses the same API that my front end, then how is it possible that it was fast now? Now, that is the thing that happens in the beginning. Now this feature is implemented, this is why it was fast, but let me explain what's happening. So let's say you shout out this sentence. I don't want to say because it understands that. So you shout out this sentence, and then usually you wait, and you wait a little bit more, and wait a little bit more, and bam, after like 10 seconds, the AC turns on. You already forgot that you commanded something. So this is a problem, right? Because essentially what's happening is that I am here, my device is here, the Google Assistant is there, and despite these facts, the communication chain is going to be long. I talk to the device. I talk to the device is talking to the Google Home backend, who is talking to my backend, and that is going to command my other device, right? So that's kind of crazy. And this is why the local communication feature is implemented in these kind of things. What happens then? The local control is happening through implementing UDP and TCP interfaces. The UDP interface is for identification and discovery. So what's happening is that on UDP, this device sends a broadcast on the local network that, hey, is there any this kind of device? And my device understands that broadcast message, and it responds that, hey, yeah, here I am. So from that, the Google knows how to directly command my device. And from there on, if my device is online, he's going to try first on the local network to deliver the command. And if that is unsuccessful, then it goes on the long run.
Wasn't it because of the cloud functions more you use it, the faster the reaction? Like because it's basically container provisioning in the backend, so when you first push the button, it's going to be slower and then faster. I think even with that, it wouldn't be fast enough. So if I try to command from here again, it takes time. So I think what's happening is that my device knows that here is this Google Home, so he talks to that, and that is capable of talking directly to my device. But this is something that would be interesting to analyze. Yeah, I'm gonna look into that.